So the last lesson for our unit is about rational and irrational numbers. And so you've been learning about rational and irrational numbers. So we're just taking like an extension to it. So your standard here is to explain why the sum or the product of rational numbers is rational, why the sum of a rational number and an irrational number is irrational, and then why the product of a non-zero rational number and irrational number is irrational. So we're going to look at like some actual examples of why this is what it is. Okay, so keep in mind like what we're going to be doing with this lesson is adding or subtracting or multiplying rational and irrational numbers to figure out what the end result will be. Okay. And so like your learning target is that you can perform those operations on rational and irrational numbers and compare and contrast. Okay. All right. So one of the things here is that when you add two rational numbers together, the sum is also a rational number. Okay. And then the other one of your statements is that when you add a rational and an irrational number together, the sum is irrational. Okay, so first I'm going to go to the next slide and then I'm going to come back here. Here's your difference. Okay, so you have inside this bubble rational numbers. Okay, so whole numbers like 0, 72, your normal counting numbers, 20, your integers, so it includes negatives. And then anything that can be written as a fraction, your decimal values, and your repeating decimals. So if you ever have a repeating decimal, it is rational as well. Okay, so all of these will be considered rational. Over here, you have your irrational. These are numbers that have a non-terminating decimal, meaning it goes on and 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 on. So like, for instance, pi, that is a never-ending number. So square root of 2 would also be a never-ending number, square root of 62. Pretty much anything, if you see a square root and it's not like a perfect square, then it's going to be irrational. Okay, so I'm going to go back to the other slide. So here, 5 is rational. 0.25 is rational. When you add it together, you get a rational number. A half is rational and a third is rational. When you add those two together, you still get a rational. Okay, and then same thing with the last one. Excuse me. All right, and then over here, square root of 2 is irrational, 5 is rational, and you can't really add those together. So that's why it stayed like that. And so it stays an irrational number. 3 plus pi is just 3 plus pi, and it stays irrational. And then same thing with the last one. Okay, so let's go through a few examples of what you will actually see. So here it says to simplify and then decide if it's rational or irrational. Okay, so they both have square root 5s. Okay, so I can add the numbers in the front together. -2 plus 2 is 0. Okay, so these just cancel out. This just equals 0. Okay, and then 0 is a whole number, which is a rational number. So this would actually be a case where when you started, you had two irrational numbers and you ended with a rational number. Okay, so that's actually can happen. So this is an example where an irrational plus another irrational equals a rational. Okay. All right, example 2. We're going to do the same thing. We're going to simplify it first. Hopefully you realize the square root of 16 is just 4. Okay, and then I'm going to bring down the plus 4. and now I get 8. And 8 is a rational number as well. Okay, so let's look at example 3. Simplify and decide if this is rational or irrational. Okay, pi stays pi. You can't do anything with that. Plus the 16. Now square root of 4 is 2. So I'm going to multiply that times 2. Pi plus 32. You can't actually add those together. Okay, pi is irrational. And so this final answer would also be irrational. All right, and one more example. Simplify and decide if the answer is rational or irrational. Okay, so I'm going to try to simplify the square root of 6 first. So I'm dividing that by 2 to get 3, divide by 3 and get 1. There's no pairs, so it stays the same. So the -3 square root 6 stays the same. Okay, over here, I'm going to do 54. If you divide that by 2, you get 27. Divide that by 3, you get 9. Divide by 3 again, and you get 3. And divide by 3, and you get 1. Okay. So here you have a pair of 3s. So that's going to come out. So that minus sign, I'm going to drop it down with a 3 on the outside. Okay, and then on the inside, I will have this 2 and this 3, and I'm going to multiply it together. So my pair came out, the other 2 stayed in. So this is -3. All right, 6 minus 3 radical 6. And then now, since these both have a radical with a 6 in it, you can add the numbers in the front. It'll be -6 radical 6. And that final answer here is irrational. So you have to simplify to figure out if it is rational or irrational.